Moving over to example number 3. Y is equals to a plus b e raised to power minus 2x. So we'll call this equation 1. We have to find the ordinary differential equation that is corresponding to this equation. Here we see that this equation contains two constants. So what we should do, we differentiate 2 times. Differentiating once, dy over dx is equals to, if you differentiate a, which is a constant, is going to have 0. If you differentiate b e raised to power minus 2x, going to have minus 2 b e raised to power minus 2x, because the coefficient of x at the power, which is minus 2, going to multiply everything raised to power the initial power. That's why we're going to have minus 2 b e raised to power minus 2x. If we look closely, we have two constants. Therefore, we need to differentiate 2 times. We have differentiated once. We have get this. We need to differentiate again. This is equation 2. Differentiating again, we're going to have the squared y over ds squared is equals to this coefficient of x, which is minus 2, is going to come and multiply the whole equation. We're going to have minus times minus going to plus. 2 times 2, 4. 4b e raised to power minus 2x, equation 3. And if you look closely, we can make this equation, we can make this to be equal to this, so that we substitute dy over dx for this. We can still say the squared y over ds squared is equals to minus 2 bracket minus 2 b e raised to power minus 2x, because this thing is still the same thing as this, just that I factored out minus 2, so that it will look like this equation, so that this will be equals to this, and this is equals to this. Therefore, we can substitute for dy over dx for this, equate everything on one side, equate everything to 0, to get our ordinary differential equation that is corresponding to this equation. So looking at this, still the same thing with this, equation 4. Therefore, we say the squared y over ds squared is equals to minus 2, since dy over ds is equals to minus 2b e raised to power minus 2x, minus 2b raised to power minus 2x, so minus 2 dy over dx. Therefore, we say that the squared y over ds squared, this is negative, crossing it over will give us positive, plus 2 dy over dx equal to 0. Therefore, this is our ordinary differential equation that is corresponding to this equation. Then we'll move over to example number 4. Example number 4, y is equals to e raised to power minus 3x. There is no constant here, therefore we need to differentiate once. Therefore, dy over dx is equals to minus 3 e, the coefficient of x, which is minus 3, come to multiply the whole equation, minus 3 e raised to power minus 3x. And if you look closely, this equation does not contain any constant. Therefore, we need to differentiate once. So we can't differentiate more. We can't still be going to differentiate more. We only need to differentiate once. And if you look closely, we can make this to be equals to y is equals to e raised to minus 3x. We can just factor out this 3 to make e raised to minus 3x equals to this e raised to minus 3x, which is equals to y. Therefore, we can still say dy over dx is equals to minus 3 bracket e raised to power minus 3x. Therefore, we'll substitute this for y, since y is equals to e raised to power minus 3x, and we have e raised to power minus 3x. Therefore, we have dy over dx, which is equals to minus 3y. Therefore, dy over dx is negative here, crossing over will be positive, plus 3y is equals to 0. Therefore, we say that this is the ordinary differential equation that is corresponding to this equation. Then we'll move over to example number 5. Example number 5, y is equals to cos 4x. We have no constants here, so we are to differentiate once. So if we differentiate once, the y over dx, if you differentiate this, differentiating this the traditional way will be cos x will be y is equals to cos 4x. Differentiating the traditional way, you say let u equals to 4x. Therefore, du over dx is equals, differentiating 4x is going to give you 4. Therefore, y is equals to cos u. dy over du, differentiating y with respect to u, differentiating cos u with respect to y is going to give us, differentiation of cos is going to give us minus sine u. Therefore, the derivative dy over dx is going to be du over dx multiplied by dy over du, which is equals to, du over dx is 4 multiplied with dy over du is minus sine u. Therefore, you have 4 times minus, that is minus 4 sine u. But u is equals to 4x, therefore you have minus 4 sine 4x. Therefore, differentiating cos 4x is going to have minus 4 sine 4x. But I won't advise you to solve these, to differentiate these using the traditional way, because it's going to take more of your time. Example, in an exam situation, if you're in an exam situation, you might not have much time. So this is my shortcut to differentiate this cos 4x. What you need to do is differentiate the content. The content of this cos 4x is 4x. If you differentiate the content, whatever you get as the content, multiply it with the differential of this cos, plus multiply it with the differential of this cos multiplied with the initial content. This is how I do it. What is the differential of 4x? If you differentiate 4x, you're going to have 4. Multiply with differential of cos. What if you differentiate cos? What you're going to have? Minus sine multiplied with the initial content, which is 4x. 4 times minus sine is going to give you minus 4 sine 4x, and this is equals to the same. This is still the same thing as minus 4x. Let me go again so you understand more. Differentiating cos 4x, what you do is differentiate the content, which is this 4x. If you differentiate the content, 4x is going to have 4. Multiply the 4 with the differential of this cos multiplied with the initial content. Therefore, differential of this 4x is going to give us 4 multiplied by, if you differentiate cos, you're going to have minus sine multiplied by the initial content 4x, you're going to have minus 4, because this 4 is going to times this minus sine, minus 4 sine 4x. This is it. So dy over dx is equals to minus 4 sine 4x. And if you look here, we cannot make anything the subject of the formula, and we cannot factor anything to look like what we have in equation 1, which is y is equals to cos 4x. So here we are helpless, and all we need to do is to differentiate the second time. We have, so the squared y over dx squared, the squared y over dx squared is equals to differentiating this the second time. If you differentiate this the second time, differential of the content, which is 4x, if you differentiate the content, which is 4x, it's going to give you 4. 4 multiplied with minus 4 is going to give us minus 16. Multiplied with the differential of sine. If you differentiate this sign, you're going to have cos. Therefore, minus 16 cos 4x, minus 16 cos 4x. And if you look closely, we can factor out minus 16. So we're going to have cos 4x as to stand alone. So we substitute for y to get our another differential equation. Therefore, we say the squared y over dx squared is equals to minus 16 bracket cos 4x. Since y is equals to cos 4x, we can substitute this for y to have minus 16y. Therefore, move everything to the other side to equate everything to 0 to get our another differential equation that will be corresponding to this equation. Therefore, we have the squared y over dx squared is equals to minus 16y. Therefore, we have that the squared y over dx squared, the squared y, therefore we have that the squared y over dx squared, if you move this 16 to the other side, it's going to be positive, plus 16y equals to 0. Therefore, we say that this is the ordinary differential equation that is corresponding to this equation.